Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Leave similar trees. So let us first read this question, then our constraints, and then examples, and then finally the coding part for the same. So now here we are given consider all the leaves of a binary tree from left to right order. Value of those trees, the value of those leaves form a leaf value sequence, and the condition for the same is, for example, here we can see 6, 7, 4, 9, 8 are leaves of this particular binary tree, right? So the leaf value sequence is this only, the way leaves are there. And then comes the part two binary trees are considered leaf similar if their leaf value sequence is same. Return true if and only if two given trees with head nodes root 1 and root 2 have leaf similar. Means basically whatever binary tree is being given to us and whatever second binary tree would be given to us, and when we take the leaf value sequence of those two trees, if they are similar by values also and even by positioning, then it is a then we can say that they are equal in that sense. Now comes the next part. Now the constraint. So constraint is given in that manner so that order of n solution could easily work here. L log n could also easily work here. So that's how the constraints are being given to us. Now comes the part that how we will be doing this question. So now comes that how we will be doing. So the thing is, now if we do BFS or DFS, then in that sense, what we need to do? We ultimately need to figure out the leaf node, right? We need to check whatever leaf nodes are there. These we are required to put in some auxiliary vector for this first tree as well, and whatever that second tree would be given. For both of those trees, we will be having those two separate vectors, and then after filling those two vectors, then we will be directly comparing the values which are being in these, and if both of them are equal, then in that sense, that will be true. But if they are not equal, means any one of them, then surely your answer would be false. So this is the thing which we are required to do here. The thing is that first thing we will be checking leaf of both the trees and putting them in two separate vectors. And then second thing, comparing those values. So that is the thing which we are required to do here. And according to all these operations, the time complexity would be directly order of n, and the space complexity would be also order of n. Now here n is here the number of roots or the number of nodes which are being there in tree 1 plus number of nodes which are there in tree 2, and that is what is the time complexity and space complexity both for both of these for doing this operation in both of these trees. Now let us go ahead for the coding part for the same. So here the thing would be something like this. Now here what we are doing is, here this was the main function which was being given to us. So these are the two vectors which we will be using for comparing the values and calling the first function and second function. Basically calling through first tree and then through second tree. So for both of them we are doing same operation. First we are checking that if root doesn't exist. Basically this is DFS function. So base case here is, if root doesn't exist, then we are directly returning. Else, if root left doesn't exist and root right doesn't exist, that simply means because here both of them are null, doesn't exist, right? So that's why at that point we figured out with the leaf node. So at that point we will be pushing to our vector which is being we have passed, right? And then we will be calling for a left subtree and right subtree. Basically here what we are doing is pre-order traversal. So that's why whatever we are doing all our operations at the starting and then calling our left and right subtree. Now comes the part that like this manner only, we will be filling both of the trees vector, right? And then now comes the part that after we got the vectors, right? First thing which we can do is we can check by comparing the size of both of the vectors. If size is not same, then we will be returning false. That simply represents that if size is not same, then surely there we are missing out some of the leaf values. And if we are sorry, and if we are missing some of the leaf values, right? Then in that context, the thing would be that how it could be similar. That if some of them is missing, right? So that's why we are checking at that point. Now comes the part. Then if the size is same, now comes the part for the value. That if at any point the value is not equal, then we are required to return false, else we will be returning true. So this is the thing, and this is how we are required to do this particular question. Now comes the part about the time complexity and space complexity, although that also I have already explained. Time complexity is already n plus m. If we say that n is number of nodes in the first tree and m is number of nodes in second tree, and same goes for the space complexity as well. So this was all for this particular question. If you have any doubt, you could comment it down. And just sorry for all that I'm feeling exhausted. That's why I'm feeling like that. So sorry for that thing. But yeah, if you have any doubt, you could comment that down. And yep, that was all for today. So yeah, thank you.